We're going to use calculus tools to sketch a graph of this function. First, let's write down the first derivative. So by the power rule, that's simply 2x minus 3x squared multiplied by a constant c that we'll assume to be positive. The second derivative will be c times 2 minus 6x. Let's proceed first of all to find the zeros of the function. So we'll have the equation c times x squared minus x cubed equals 0. Factor it, and when we do so, we get cx squared times 1 minus x equals 0. The only way that this can be 0 is if this factor or this factor is 0. The solutions are either x equals 0 or x equals 1 from this factor. So let's use another skill that we've learned earlier this semester, namely let's look at the powers and see which of them dominate where. Close to the origin, the term with the lower power dominates, and so the function can be well approximated by cx squared near x equals 0. On the other hand, far away, x cubed dominates, and then the function is well approximated by the higher power, which is minus cx cubed. Already from this, we can sketch roughly what the function looks like. And so near the origin, it will resemble a parabola opening upwards, and farther away it'll look like a cubic curve with a negative sign, so it'll have branches that come down like so, and it takes just a little bit of imagination to observe that the function has got to look something like this. There's a branch coming down from above, hitting x equals 0 and going back down. And so what we found up till now are the zeros at x equals 0 and x equals 1. Next, let's look at critical points. So in order to determine where are the critical points, we have to find values of x for which the first derivative is 0. And so we're going to be solving the equation c times 2x minus 3x squared equals 0. Again, we factor, and we see that the solutions to this are either x equals 0 or x equals 2/3. Already from our graph, we can tell that x equals 0 is going to be a local minimum, and x equals 2/3, which is somewhere here, will be a local maximum. So for inflection points, we must have the second derivative being 0. So again, we have to solve an equation of the form c times 2 minus 6x equals 0 directly from here, and the solution is x equals 2/6, which is 1/3.